Welcome and hello everyone. This is Hussein Galal, software engineer at Rancher Labs and one of the maintainers and contributors to RKE project. This is RKE Under the Hood. This recording will explain several topics, include RKE Design and how RKE works under the hood, how it connects to nodes, how it deploys services, and what are the main and building blocks of RKE. So this session will basically cover RKE Introduction, and then we will move on to RKE Design and how RKE is built and what are the main building blocks of making RKE. After that we'll move to RKE Provisioning and how RKE is used to provision clusters. Also we will talk about RKE Reconciliation loop, which basically explains how RKE adds and removes nodes. Finally, Sebastian is going to talk about Rancher and how it connects to RKE and how RKE works within Rancher. So let's get right into it. So first of all, what is RKE? So RKE is a CNCF certified Kubernetes distribution, which basically means that it installs a version of Kubernetes that runs entirely within Docker containers. So all the components or the main components of building Kubernetes are run within Docker containers. It works on bare metal and also on virtualized servers, and has so many options and customization that you can apply, and it works in really fast and can install a cluster within minutes. All what is required to run RKE is having servers that has SSH connection and Docker installed on them. So if you don't know anything about RKE, so RKE basically uses a cluster YAML configuration file to define the Kubernetes cluster. Each cluster YAML file represents a Kubernetes cluster configuration. You can customize your cluster configuration within this cluster YAML file. RKE Up uses this cluster YAML that you specified to get the node information and install the cluster according to what you specified in this file. So the main option here is RKE Up, and it is used with flag config to point to the cluster YAML file that you specified earlier, and it connects to the nodes and run Kubernetes. What cluster YAML looks like? So this is a really simplified version of cluster YAML. It's just a YAML file that has nodes which specify the list of nodes that you can connect to. For example, this one has only one node that has address of 10.0.0.1, and it has role, control plane, etcd, and worker. And we'll talk about what that means in the next slides. It also connects to the user Ubuntu on this node. It connects via SSH to this node and specify the node name as node 1. So I'm going to demo how to run a single cluster node with RKE Up and show you how it's really easy to get started with RKE just with a simple cluster YAML file and simple command. So I have here a cluster YAML file that only has a nodes and only one node specified, and it has the role of control plane, worker, and etcd. So if I run RKE Up, and I have here RKE version 1.0, if I run RKE Up and point to the cluster YAML file, it will connect to this node and it will start installing Kubernetes. So I installed Docker beforehand on this node because this is one of the two prerequisites to have RKE install a Kubernetes cluster on your nodes, to have SSH to this node, to have SSH connection to this node, and whatever user that you connected with must have access to Docker engine. So as you can see here, RKE starts with generating the Kubernetes clusters certificates, and we will talk about how authentication works exactly within Kubernetes and within RKE. And it starts by doing a port check on the nodes, and then pulling the images, and then starting the building the Kubernetes cluster, starting from etcd, then moving to kube API and the control plane components, and finally onto the kubelet and kubeproxy and the worker components. So here is how, as you can see, it's really easy to get started without any trouble. So let's move to what RKE consists of, what is the main building blocks of RKE Design. So the first thing that you need to know about is RkeConfig. That's basically the cluster YAML file that we just saw. It is the first building block of RKE. Basically, it defines your cluster. It's a configuration file definition that by default is called cluster YAML file, or at least what RKE is searching for by default, if you did not specify --config or the config flag. So to basically build the cluster YAML file, you can use a command called RkeConfig, which is built specifically to generate your config file and help you generating your config file for you. So again, let's see on the terminal. As you can see here, our previous command just started and finished in basically 2 minutes, and you get a full-blown Kubernetes cluster that's ready to work. So taking a few seconds, and you can see that it's getting one node and just started as a 47 seconds with Kubernetes by default, Kubernetes 1.16 that comes with RKE version 1.0, and also we are going to talk about Kubernetes versioning and how that works inside RKE. So we're talking about RkeConfig and how it's used to basically generate RkeConfig for you. So if we do RkeConfig command and does help, so RkeConfig is a multi-purpose command that can be used to generate a config file, generate an empty config file, or print it on the screen. It can also use to list system images and list versions, and we are going to talk about these two when we come to versioning. So let's start with RkeConfig --empty --print, and this basically will print a config file, empty config file that can be used as a cluster YAML. So it generates a YAML, this config file in a YAML format. As you can see here, this basically a configuration file. It has nodes which you can populate with your node information. It also has services, and we're going to talk about services in a minute, and other configuration options that can be used to customize your Kubernetes cluster. So yeah, this is one of the main commands in RKE and can be used easily to generate your cluster YAML file. So if we take a closer look about the cluster YAML file, we will see that it consists of 3 main options and also other options that can be used to customize your cluster, but the 3 main options that can be used are nodes, services, and Kubernetes version. Nodes are used, or these are the main options that originally RKE designed with. After that, we used to add other features and other specifications according to our needs. The first design building block is nodes, and nodes specify the the nodes that can be used to install Kubernetes on. It consists of a list of addresses or list of servers that can be used with different roles. Basically, it can be used as a control plane or worker or HCD. The other building block is services. Basically, this define or customize the services that will be used or be created on the nodes. These services consist of the Kubernetes components that will be installed on the nodes, including kubelet, kubeproxy, kubescheduler, controller, API servers, and finally HCD. Finally, there is another option a really important option that we're going to talk about in depth which is Kubernetes version. This specifies the Kubernetes version that you're going to install on your nodes. So let's jump ahead to a topic: what happens when you run RKE up. So when you finish running RKE up, you get a full-blown Kubernetes cluster. However, you also get some files installed on your system when you run RKE up. These files are the RkeConfig and another file called cluster.rkestate, which is basically the state file of your cluster. So RKE needs to keep track of the cluster status to modify the cluster afterwards, or to do any modification to your cluster. Basically, if you need to remove a node or add a node, RKE has to have an idea about the previous state of the cluster. So originally we had originally we used to store the state on the nodes themselves and on the Kubernetes cluster as a secret. However, this created some inconsistencies between the nodes, and we moved to a new state management, and this basically consists of creating a cluster RKE state file on the disk from the place that you run RKE from. So the state file consists of two sections: desired state and the current state. The desired state represents the state of the cluster that should be in. However, the current state represents the actual state of the cluster. So both current and desired state consists of RkeConfig and the certificate bundle. So the state file consists of two sections: the desired state and the current state. The desired state basically represents what you want your cluster to be in, what state of the cluster that should be in. And however, the current state works differently. This describes what the actual state of your cluster. The desired state is populated from the cluster YAML. Basically, this is cluster YAML is a desired state is a translation of cluster YAML, and that happens when you run RKE up. RKE up translates the cluster YAML and store it in the desired state. After that, it continue with the installation according to what desired state is, and after it installs it applies the desired state onto your cluster, and then updates the actual state with this information to match the desired state. So this is what the cluster RKE state looks like. It consists of desired state, as we talked about, and the current state. Desired state consists of the RkeConfig, which is a cluster YAML, and certificate bundle, which RKE generates. After RKE finish installing the RkeConfig and the certificate bundle on the nodes and creating the Kubernetes cluster, it stores it saves the current state, which is the actual state of the cluster, and that's how any updates work. So any other update that you apply, it applies to the desired state, and RKE then compares the desired state with the current state and apply only the differences on the cluster. So let's move back to what we talked about in the cluster YAML. We have nodes, we have services, and we have Kubernetes version. let's talk or take a closer look about the nodes. So we said that there are the two prerequisites of connecting to the nodes or having RKE works for you with your nodes is having SH enabled and Docker to be installed. So that's how we get RKE to connect to the nodes. We use a SH tunneling, we use SH forward feature to connect to the TCP, to the Docker socket, to the Unix Docker socket installed on the nodes. So RKE uses SH tunneling to connect to the Docker socket on each node over SH connection. So each node config should have at least the following defined in the cluster YAML: the address, the SH user, and the role. So this is example of a node in the cluster YAML which has address, it has a role, it has a user. Also there are extra information that you can define, like the port, the internal address, the hostname override, which defines the name of the node. So not only we created a tunneling or securing way to connecting to the node, but also we created a generic way to use RKE library with any other tool. So the tunneling to the nodes is not the only way that you can connect to the nodes. However, there are other modes in RKE that depends on other ways or other methods to connect to the nodes. For example, RKE local or RKE Docker in Docker connects to the node using different method. For example, RKE Docker in Docker uses the TCP IP port of the Docker container of the Docker engine to connect to the node. However, in RKE CLI, it uses the method that we discussed before, which is SHing to the node and using SH forward to create a tunnel and connects directly to the Docker socket. After that, RKE installs or run containers through this Docker socket on each node. So the second building block that we need to look at closely is services. So what exactly RKE deploys on the nodes? So RKE deploys the master components and the worker components on the node. The master components including etcd and including control plane, and the worker components includes the kubeproxy and kubelet. So we have basically three roles in RKE: etcd, control plane, and worker. So etcd includes etcd container, control plane includes API, controller manager, and scheduler. Finally, the worker includes kubeproxy and kubelet. But you may notice that also etcd has kubelet and control plane has kubelet as well. That's because we want etcd nodes and control plane nodes to be registered with the node objects in Kubernetes, so that when you do kubectl get nodes, you will see the node listed there, and you can manage the nodes from there. However, we disabled scheduling on these nodes unless for critical paths like the networking paths. Plus, using these three roles, we also run some helper containers that you may notice when you do Docker PS on one of your nodes. This includes sidekick container that include all the files that can be used within the main component. We also run a port check container that checks that connection between the nodes. We also run etcd operations, including snapshotting and restoring using the helper services. Also, we deploy the certificate and files using these helper services as well. So the third thing that we want to talk about in the cluster YAML is version. The versioning in RKE works by mapping RKE version with a list of Kubernetes versions. So each RKE version comes with a default Kubernetes version and a list of supported Kubernetes versions. So how can you actually know what versions are supported through this RKE release? So when you have RKE, you can do a simple command called RKEConfig-L-A, and you can list what Kubernetes version are supported in this RKE release. Also, you can do RKE-L only, and you'll get the default version that will be installed. So, for example, if you want to pin your Kubernetes version to a specific version, you can add Kubernetes version to this version in your cluster YAML file. So each version of Kubernetes also comes with a specific versions of the Docker containers that will run on this node. So for example, Kubernetes 1.16 comes with Hypercube 1.16 and comes with a specific etcd version as well. That also applies on the ingress images, ingress controller images, or the DNS and network paths. So each Kubernetes RKE version comes with a supported list of Kubernetes version, and each Kubernetes version comes with a supported list of system images. You can also pin a specific system images into your cluster YAML file by using system images option, and you can specify underneath what image exactly you want to specify. This mapping happens in a repository called container driver metadata in our Rancher repo. So moving on to another topic, what exactly happens when you run RKE up? So RKE up itself consists of two methods. It contains a method called RKE init, and which is implicitly ran within RKE up, and then it moves to RKE up, which runs a function called the cluster up. So basically we have our cluster init and the cluster up. So the cluster init is responsible for updating the desired state. So we talked about that how the cluster RKE state consists of desired state and the actual state called current state, and how RKE translates the cluster YAML to the desired state. So the function that's responsible for updating the desired state with the cluster YAML is called cluster init. Also, cluster init is responsible for generating the certificates. So cluster init generates certificates and translate cluster YAML and store the desired state, and writes a new cluster RKE state file. However, cluster RKE up, what it does is compare the desired state with the current state and apply what is missing in the current state from the desired state. So for example, if we have one node missing, or you added a new node, then you have a node missing in the current state, so this needs to be updated and installed into your cluster. Also, it deploys the cluster components on the nodes. So it deploys the etcd plane, the control plane, and the worker plane on the nodes. So the cluster up is responsible of actually building your cluster and updating the current state with the new or actual state of the cluster. So here is a simple workflow of how RKE works internally. So we talked about cluster init and the cluster up. So we have cluster init, which reads the current state. If it finds an already certificates found there, it only regenerates the missing certs. If it doesn't find anything, this means it's a new cluster, so it generates the certificates, it updates the desired state with the cluster YAML, and then write a new RKE state file. So after that, cluster up read the state file that has been written by cluster init, and then tunnel to the hosts, as we talked about, via SSH, and then deploy the certificates, reconcile the loop, which we'll talk about in a minute, and if it doesn't any state found, if it's a fresh cluster, it deploys etcd plane, control plane, and write the current state, and then worker plane, and finally deploy the add-ons and the network. If it already found a state there, it turns into something called a reconciliation loop, which basically add or remove a node. So before we move to the reconciliation loop, which will be the last topic that we talk about in this talk, we will talk about component authentication. So Kubernetes uses different methods for component authentication, and that includes basic authentication or static tokens. Also, it uses client certificates, which is X509 authentication, which uses a master CA certificate to verify the client connection that presents a client certificate. So in RKE we generate a master CA certificate, and we sign everything underneath with this master CA, including a certificate key pair for each service. For example, kubeAPI has a certificate, scheduler has a certificate, controller has a certificate, kubelet also, and kubeproxy. We also generate an etcd certificate for each etcd node, and we generate a proxy client certificate, which is responsible for the aggregation layer, and finally a service account token. So to visualize what we talked about, this is a simple diagram that explains how authentication works within RKE. So we have the API, which has its own certificate, kubeAPI certificate. The kubeAPI certificate connects to etcd with this certificate, and each etcd node has its own certificate as well. The proxy has a certificate, scheduler has a certificate, and controller has a certificate, which all of them presents to the API. The API then uses a master CE certificate to verify that this client certificate has been signed by the master CE, and if it's signed by the master CE, it accepts the connection, and if it's not, then it disconnects. The kubelet has a special case because the kubelet itself has a kubelet API, which can be used to collect metrics for the nodes and other stuff. The API also present a kubeAPI client certificate, and kubelet also verify this client certificate using the master CA. So yeah, that's how component authentication works. So finally, let's move to reconciliation loop. So every time RKE up runs, it compares the desired state and current state. So if it finds a new node in the desired state, which means that you added a node to your cluster YAML file, and this node needs to be added to your cluster, it checks for the node and check for the role of the node. If it finds that this node is an etcd and not already a member of etcd, it adds the etcd member to the cluster, and this equivalent to etcd-ctl member add. After that, it runs etcd on the new node, and if it's a worker or control plane, it continues with the installation normally, which basically runs the etcd plane, control plane, and worker plane. Removing is another matter. So removing a node meaning that we need to check for the role first. If the role is etcd, we remove it from the etcd cluster first, and then remove it from Kubernetes, which is the second step here, and then finally we clean the Docker container that we installed on this host. If it's a control plane, we delete the node from Kubernetes cluster and then remove the Docker container. And this happens every time you run RKE up, and if the desired state is different from the current state. So this is an example. So we have here the desired state, which is RkeConfig has a node, has a one node, and you added a new node to your cluster. So you will see that the desired state has a new node, but the current state doesn't have any node. So RKE compare the current state with the desired state, and then it adds this new node to the cluster. So yeah, that was the part about RKE up. I'm going to stop the recording now, and Sebastian will take it from there and explain how Rancher is connected with RKE and how Rancher uses RKE to manage clusters. Thank you.